Okay, hope everybody had a good weekend. Just a couple things before we go ahead and get started. We're now done with our units, or I should say sections, over graphing all 6 of the trig functions. We're going to get a little more practice on that, as we go forward. But we're 3 weeks out from the end of the semester, so all these last grades, are going to be really important. This homework grade, you got a test grade coming up on Friday, probably have another quiz grade next week. So please make sure you're taking time to look over your material, bringing your notes with you to class. If you have any questions, come on in. Let me help you with those, just so that we can make sure everybody's going to be in a good position in a couple weeks' time when we're about ready to take the final. As far as the test goes, that's coming up, like I said, on Friday, the 7th. You got 4 days from now. You can use your notes just like we always do. Part of it's multiple choice, some of it's open-ended, but it's all, the vast majority of it's going to be over graphing. You've got one problem on there where you're going to have to graph, very similar to what you were doing on the homework. I've got the format actually set up like that quiz you took last week. And then just as a couple of review problems, I put a few law of sines and some law of cosine problems right at the end of that. So I don't think it's going to be anything too terrible, but you'll be asked to find the amplitude, the period, the frequency, all that good stuff. So again, if you have any questions, let me know. Now, our next unit in trigonometry, we're going to start looking at inverses. We're going to go into a little more detail on those, sine inverse, cosine inverse, tangent inverse. But we're going to be using triangles to help us out. All right, so those triangles are going to be special right triangles. Now, when I say special, I'm talking about the 30, 60, 90 and the 45, 45, 90 triangles. And we've brought them up here, in class from time to time, but I thought it would be a really good idea, take a day or two. Let's revisit the topic. That'll make it a little easier when we're going into the inverses, okay, and we identify what it is we're talking about. Okay, so special right triangles, 30, 60, 90. Well, the short leg is always, typically they're using n here, we'll use x, but the variable itself really doesn't matter. But the shorter leg we always call, I guess in this case, n. Okay, you can call it x, whatever you like. Now, the other two sides are always going to be written in terms of that shorter leg. The hypotenuse is always going to be exactly double whatever the shorter leg is. Okay, yes? I even mentioned the focus activity, and I went right into the lesson. You're absolutely right. Sorry about that. I was so ready to get into the lesson. Dadgum. Too excited about math. All right. Well, here is our focus activity. This is our third one of the 6 weeks. And it says, a vertical flagpole is attached to the top edge of a building. A man stands 400 feet from the base of the building. From his viewpoint, the angle of elevation to the bottom of the flagpole is 60 degrees and to the top is 62.5. Determine the height of the flagpole. Okay, so I've already kind of started drawing the figure here. So here's the ground, the building, and this segment here is going to be the flagpole. So there's the flag attached to it. Okay, yeah, it actually turned out pretty good. But let's say that there's a gentleman standing on the ground, and he's looking up at the flagpole, both at the base and the very tip of it. So let me go ahead and draw these right here. So he's standing right here. So he's looking to the base, and he's looking to the top. Now, the angle of elevation to the bottom of the flagpole is 60 degrees, right? So this angle right here is 60 degrees, but the angle to the top, the bigger one, that's 62.5 degrees. Well, I've got 2 triangles, but what kind of triangles are they? Yeah, they're right triangles because this building is going to be perpendicular with the ground, right? So I've got one triangle inside of another. Let me go ahead and kind of highlight these. Right here, this one in green. Okay, so this one here has the 60-degree angle. And we know that the base of this, the guy is standing 400 feet away, so I know the base of that one is 400. And then I can do the same thing for the larger triangle. Let me go ahead and choose a different color here. All right, so I've got this larger one. I'm not able to trace today very well, so that's okay. The larger triangle, so his angle is 62.5 degrees, and it still has 400. All right. So given this situation, well, how am I going to figure out what the height of the flagpole is? Like, what can I do?
We'll split the 60, right? Since we know like that was the right triangle.
Uh-huh.
That 90 was 30 up, so you know it's like
There you go. Not very many people today have recognized that as a 30, 60, 90. So you could go ahead and say that. Now, the height of that triangle in green actually represents what in my diagram? What height? Height of the building. So that triangle right there in green, if I highlight this height, well, that's the height of the building, right? Okay. Well, actually, this is something that we're about to discuss, is how to figure out the sides of a special right triangle if you're only given one. Well, what we can do, the side across from 30 is always my smallest side. So this is 400, right? Do we know what the hypotenuse would be? It's always double the shortest leg. So what's 2 times 400? 800. And now for the other leg, we take the shorter leg and multiply it by some radical. Okay, by not 2. Okay, it's 3, but it's a square root. So 400 square root of 3. Okay. And this is perfect because it leads right into the little review lesson we're going to do today. When you're talking about a 30, 60, 90 triangle, what's across from 30 is always our x, okay, our shortest leg. Whatever's across from 90, the hypotenuse, is always double the shorter leg. And the other leg, the longer leg, is always the shorter leg times the square root of 3. It's always going to have that relationship there. So if you always know one side, you can always find the other two pretty easily. Or if you find 2, then you can just use the Pythagorean theorem. Okay, so we have the height of the building. We'll go ahead and approximate that in just a second. 400 square root of 3. So this one right here, let me use another color. Let's use blue. The height of this triangle, what would he be? There you go. It's the height of the building plus the flagpole. Well, if I had these two heights, well, what can I do? Yeah, if I just subtracted the 2, that difference has to be how tall the flagpole is. Now, can I go ahead and use a special right triangle for this one? Now, see, it's close, but that angle isn't 60, it's 62.5. So I need to figure out what that height is. Now, it's a right triangle, so what would x and 400 be to 62.5? There you go. X would be the opposite, 400 would be the adjacent. What's a trig function that uses those two? Tangent. Perfect. So I'd go ahead and say tangent of 62.5 degrees equals, and then we put our ratio, just like we've done a long time ago, when we first started looking at trig. So the opposite x over the adjacent 400. Well, it's been a while. How would I solve an equation like that for x? Yeah, I just multiply by 400. So times 400. So times 400. So this expression here is going to give me the total height, the flagpole and the building. The other one, the 400 square root of 3, is just the building. Well, if I go ahead and subtract the 2, I'm going to have my answer. Well, let's see here. I don't even need to know what they are individually. I'll just go ahead and put them in the calculator. 400. Okay. Oh, and I kind of figured it would do that because I'm using those different colors. Let me go back over here real quick. Let's see if it'll let me go back. If I click that mouse button, maybe. 400. There we go. Then it was tangent. What was it, 62.5? Okay. And then we're going to subtract. It was 400. I believe it was just the square root of 3. All right. As soon as I push enter, I'd say our height's looking at about 75.6 feet, the height of the flagpole. There we go. Okay. So about 75.6 feet. There we go. And actually, one interesting thing for this smaller triangle right here, the one that's green, if it wasn't a 30, 60, 90, could I have also set up a trig expression to help me with that? Yeah. I knew the base was 400, and I was looking for this, so I could have easily set up a little trig ratio using tangent again. Perfect, perfect, perfect. Did anybody happen to have that solved before we got started? No? Oh, Antonio? Okay, good, good, good. All right, well, you have 3 now. I've got the 4th one printed up and ready to go. I'll be giving you that later in the week. I'm hoping to get 5 in this set, but we'll kind of see how that plays out. Maybe 4 will be it. But if you get a 5th one, it'll be next week. But I'll be letting you know when to turn those in. I remember a little while ago we were talking about, making sure we're staying on top of our assignments and everything. This right here should be a guaranteed good grade. All you got to do is keep up with them, work them together, and just turn them in. Okay, good. All right. Okay, well now, let's turn our attention back to this over here. And actually, working that problem kind of helped us out with this introduction. The shorter leg is always x. I mean, here we can call it n. Okay, the hypotenuse is always double the shorter leg, and the longer leg is always the shorter leg times the square root of 3. Okay, and you don't always have to go ahead and know the shorter leg. If you know the hypotenuse or if you know the longer leg, well, then you just kind of work backwards. Okay, so let's go ahead and put a little practice into this. Find the value of x and y in each triangle. Okay, so this is a 30, 60, 90. 30. Okay. Now, in the beginning, do you guys want me to go ahead and put the expressions? Let me show you what I mean. In terms of the variable, like here they're using n, right? So across from 30, we always have n. Across from 60 is always that shorter leg times the square root of 3. And across from 90, the hypotenuse is always double the shorter leg. Well, see, what you're going to do is start with the one side you know. I know that this side should represent n, but I actually know its length is 8. So that tells me what? What does n equal? N equals 8. So once I know that, it's just a matter of plugging it into the other two sides and seeing what they're got to be. So what is double n? Okay, 16. And if n is 8, then n square root of 3 would be 8 square root of 3. There you go. You can easily find the other two sides. Now, does anybody want to revisit this one, choose two sides, and use the Pythagorean theorem to see that we'll match up with the third side exactly? Does anybody want to do that? No? No. Okay. And it's okay. I mean, even sometimes I'll walk in, 2n plus 2n will be 4n to me. 4n to me. Because we had the expression 2n, I figured I kind of worked that in a little bit. It's been a weekend, so you probably wanted another joke, I'm sure. That was impressive, yeah. Well, it kind of went with the 2n we had here, so there was a little segue into it. Yeah, 4n's nothing in the problem, but 4n, like it's foreign to me, I understand it. There you go, yeah, okay. You'll laugh later. All right, number 2. All right. So I have another 30-60 triangle, and it doesn't matter how it's oriented if you know the sides. I know across from 30, here's my n, and I'm not using x as we typically do because they already have x and y, and I don't want to confuse you with that. So across from 30 is always length n. Across from 60 is the shorter leg times the square root of 3. And across from the 90, the hypotenuse is always double the shorter leg. It's always the same relationship. Well, do we know n? What is it? It's 1/2. Okay. So for this hypotenuse right here, x would be double the shorter leg. So that's just 1. Okay. And I know that y would just be 1/2 that shorter leg times the square root of 3. So if I were to go ahead and multiply those together, how would I write it to something that we've seen before? Well, you don't need to, because where's that radical? There you go. So it'd just be square root of 3 over 2. Because if I wanted to actually go ahead and multiply these, I'd probably just go ahead and put square root of 3 over 1, and then just multiply straight across. Okay. All right. So I'll go ahead and talk about this last one again in terms of the sides, and if you want me to keep doing that, I will. If not, you guys can just start telling me what the side lengths are. So let's see. Across from 30, that's always the shorter leg, so I know that's n. This would have to be 60. Across from 60, the longer leg is always the shorter times the square root of 3. And what's the hypotenuse in terms of n? It's always double It's always double the shortest side, right? Okay. Well, can anybody tell me what's the value of the longer leg? The longer leg. So what's across from 60? There you go. I can see here that n is equal to 14, so I just substituted in. 14 square root of 3. So what's 14 doubled? 28. That's it. Okay. All right. Hopefully this is coming back to you. This is what's going to make the next section really easy for us. Being able to identify these special right triangles. Okay. All right, let's try this one. Number 4. So let's see, if that's 30, that one has to be 60. Do you want me to keep rewriting the expressions around the sides in terms of n? Or do you guys feel okay with my not doing it? What do you prefer? So not do it, just tell me the sides?
Yeah, like.
Okay.
So, like, these 3, can you do it the next 2 weeks?
Oh, okay, so you want to do one more together and then you try the other 2? Let's do that. Okay. So here we go. Now, I will say that starting with number 5, it does something differently, and I'll mention it in just a second. All right, so across from 30, that's always the shorter leg we call n. Across from 60, that's the longer n, where you take the shorter and multiply it by the square root of 3. Across from 90, the hypotenuse, that length is always double the shortest leg. See, it's always in terms of the shorter leg. What's across from 30? So let's see. What's the value of n? Yeah, it's got to be 12. All right. So, Rhett, what is the value of y? What would the longer leg be if n equals 12? Remember, if that side is n square root of 3, and I know n is 12, nope, so we have n square root of 3, but we know n equals 12. So I'm only going to replace that variable. So the square root of 3. So it'd be 12 square root of 3. There we go. Perfect. Okay. And Christian, the hypotenuse is 2n, but I know n is 12. So the hypotenuse has to be 24. Okay. Now, if it gives you the shorter leg, I mean, it's pretty easy to go ahead and work backwards. But now, I said there was something different about number 5. What am I referring to? There you go. They're giving me the long leg. They're not giving me the shorter. So it is a matter of substitution, but I'm going to have to do a little bit of algebra to figure out what n is. Because if this one's the 30, across from 30, we always have the smallest side n. Across from 60 is always n square root of 3. And then the hypotenuse, let me get rid of this guy, is always 2n, right? So see here, it's not immediately visible. We know that the length is 12, but it's supposed to be n square root of 3. So it's just like the previous problems. I'm still going to set the value and the expression equal to each other, but now I'm going to solve for n. How would I get n by itself? There we go. We got to divide by the square root of 3. So those are going to cancel. Now here, we want to go ahead and simplify this. In fact, what's the word I'm looking for? Rationalize. So 12 divided by the square root of 3. What does that mean, rationalize? What am I doing? There you go. We don't want that radical down below. Now remember, this isn't 4, because we know 12 divided by 3 is 4, but that's not really 3. So I'm going to multiply by square root of 3. Square root of 3. So this is 12 times the square root of 3. What's the square root of 3 times the square root of 3? It's just 3, yeah. When you multiply square root by itself, the radicals are going to cancel. So now we can simplify. Kind of think about the radical as a house. See, the 12 and the 3, they can't play together because one's outside, one's inside. But now this 12 and that 3 are both outside, so they can. In fact, that would be 4 square root of 3. All right. That would be my value of n. So I immediately know that across from 30 has to be 4 square root of 3. Okay. Well, how do I find the hypotenuse? What do I do to the shorter side? All you got to do is double it. Okay. So I want to double 4 square root of 3. Now here's my question. Am I going to multiply that 2 by the 4, the 3, or both? Just the 4. Remember what I said a second ago? Is this 2 in or outside of a radical? He's outside. He's not even part of a radical, right? So the only one he can interact with is any other number outside. The only way this 2 could affect this 3, which is inside, is if the 2 was inside himself. So I'm going to go ahead and say 8 square root of 3. Does that make sense? Okay. Now you'll notice number 6 is the exact same type of problem. Okay. So I'll leave it up to you. Do you want to go ahead and work this one together again? Or would you like to try it on your own? Try it on your own? Okay. So I'll leave that work right there. Actually, I'll go ahead and move this over here. So it looks like we have the base to be 8, and that would be the longer of the 2 legs. And in fact, if you wanted to confirm this, in order to get the length of the longer leg, we always take the shorter leg and multiply it by the square root of 3, right? Well, on that previous problem, we found the shorter leg to be 4 square root of 3. 4 times the square root of 3. Well, I'm going to multiply that by the square root of 3. What's square root of 3 times square root of 3? 3. And what's 4 times 3? See, that's what we originally started with. So the relationship is still there. Okay. So this one would be 30. Now remember, across from 30 is always the smaller leg. Across from 60 is always the shorter leg times the square root of 3. And across from 90 is always double the shorter leg. And thinking of this lesson right here, it just kind of reminds me about why obtuse triangles are always so sad. Because they're never right. Because they're never right. Thank you. I'm here for the rest of my life. Okay. There you go. Yes. I do. Oh, yeah? You still have way more hair than I do. So. It's pretty cool. I got the get up and go haircut. I get out of bed, ready to go. One less thing to worry about, that's right. Very cool. Very cool. All right. Does everybody think they're about ready, or do we need a little more time? Think we're about ready? Okay, so let's say we wanted to solve a problem like number 6. Well, we don't immediately know the value of n as we did in numbers 1 through 4, so we have to set up an equation to help me. The only side length I know is 8, and I know the expression has to be n square root of 3, so I'm going to start there. Okay, so how would I solve for n? Divide by the square root of 3. Okay, so that does give me n, that's the good news, but we want to try to simplify this as much as possible. So we're going to rationalize it. Okay, so 8 over the square root of 3. That just means I want to remove the radical, so I'm going to multiply the denominator, but I got to multiply the numerator by the same thing. So what do I have up top? So 8 times the square root of 3. See, they can't interact with each other over what? 3. Okay. Now, can those 3's cancel? No, because again, that 3 is inside, so they can't interact with each other. The 8 and the 3 won't simplify, so that has to be n. 8 square root of 3 over 3. Okay. Well, how in the world do I go ahead and get the hypotenuse if I now have the shorter leg? You just double it times 2. Now, here's the thing. Let's say I want to multiply 2 times what I just got. 8 square root of 3 over 3. Will I multiply the 2 times the 8, the 3, or both? Just the 8. If you're wanting to multiply a whole number by a fraction, I would probably encourage you to make it into a fraction, and then you just multiply straight across. So the 2 can only multiply by the 8 because he's outside, right? So can anybody tell me, what should my hypotenuse be? 16 square root of 3 over 3. Because the 1 times 3 on the bottom gave me the 3. That's it. Okay. How we doing? Doing all right? Okay. Now we are, moving on into our next lesson. This material is not going to be on your test. Okay. In fact, we may not even finish this before we get to the test, and that's okay. All right. 7, 8, and 9. Okay, so it looks like 7. So we have 30. So this one would be 60. Okay. Let me go ahead and write this out real fast. So across from 30 is always n, the shorter leg. What's across from 60? What do we do to the shorter leg to get that? N times the square root of what? 3. And then the hypotenuse is always double the shorter leg. So you'll notice this one is different again. It's not giving me the shorter leg. It's not giving me the longer leg. It's giving me what? It's giving me the hypotenuse. So I'm still going to have to create an equation, but this one's going to be a lot easier to work with. Okay. In fact, what do you think my equation is? Yeah, 11 equals 2n, or 2n equals 11. And I'll let you guys decide. How would I solve this for n? Yeah, divide through, right? So when I said I'll let you guys decide, do you want to go ahead and keep the fraction? Or do you want to go ahead and just change it to a decimal? Keep the fraction? Okay. So right there, immediately, we don't have to rationalize or anything like the previous problem. I know that n has to be 11 halves. That's it. So I know the shorter leg has to be 11 halves. Now, in order to find y, what's across from 60, well, I got to take that shorter leg and multiply it by what? Okay, times the square root of 3. So that square root of 3, is he going to multiply by the 11 or the 2? By the 11. Remember, I put him over 1 and then just multiply straight across. So this side right here should be 11 square root of 3 divided by 2. Okay. All right. You guys want to try the next one on your own? Okay. It's got the hypotenuse just like number 7, what we just did. Okay. So let me give you a few seconds to go ahead and look that over. Yes, ma'am. We actually should be finished pretty quick. I'll tell you what, you give me the answer to this one, I'll let you go. You did both of them? Sweet. What are you saying for number 8? What's x? 3. And what's y? 3 square roots of 3. Is she right? That is perfect. Yes, ma'am, you can go. And we'll get to number 9 in just a second. Perfect. Okay. Now let's see. Running through the same process, we know that across from 30, we've been calling that n in this resource. Then across from 90 is 2n. Across from 60 is n square root of 3. And you just create an equation using the side and the expression you have. So if 6 equals 2n, that's how we got that n is equal to 3. How many people got that one right? Okay, good. Well, let's take a look at number 9. This one, actually, you can do one of two things. You'll notice the bigger triangle, what'd they do? They split it into two what?
Right.
They split it into two smaller right triangles. So if you wanted to, we could go ahead and say this is 30 right here. Okay. But let's think about it. Big picture here, what's the interior angle sum of a triangle? If you put it in the tracer. If you were to add all 3 angles, it's always 180, right? So if this one's got to be 30 because this one's 90, then what's this little angle right there got to be? 30 So this one would have to be 60. So what is it that I'm trying to get you to see? What do you now notice? Yeah. What's across from 60? 16, right? But this other angle is 60, so this should be 16. What's across from 30 and 30 is 16, so I know this has to be 16. So it's just another way to go about it, you know, if you weren't going to go with the special right triangles. Okay, just kind of showing you that. All right, but if we were to go ahead and run through with the triangles, which is what we're doing today, let's see. This 16 is across from the 90, so I know that's 2n. So can anybody, what does n represent? N's got to be 8. And remember, a second ago, we had that divided into two triangles whose base was 16. So it makes sense with what we were looking at. What would y be? 8 square roots of 3. That's the longer leg. That's it. That is all there is to it. Okay. So I'll tell you what, let me go ahead and let's do one more problem, and then I'll quickly show you 45, 45, 90, and we're going to be done for the day. It says number 10, an equilateral triangle. What does that mean? All three sides are the same. There we go, equilateral. Okay, so that means I have a triangle where all three of those angles are going to be the same. Has side lengths of 10 inches. So 10, 10, 10. Find the length of the triangle's altitude. What does that mean? There you go. So from this top vertex, if I were to go ahead and drop an altitude, means it's perpendicular to the other side. I'm looking for that height right there. Okay. Well, actually, we kind of talked about this just a moment ago. If all three of these angles are the same, or should be the sides are the same, then that means all three angles should be the same as well, right? In fact, what's this lower left angle? That would have to be 60. This one would be 60. This one would be 60. Now, this angle would be 60 degrees as well, but that altitude also works as an angle bisector. So it would be 30 and 30, just like that previous one. Okay. So can anybody tell me what's the value of n? 5. Yeah, because the hypotenuse is always double the shortest side. So I know this would be 5. This would be 5. So that altitude has to be what? 5 square roots of 3. That's it. I'll go ahead and put inches. Any questions? You guys remembering this? Cool. Well then, let me show you very quickly. And this is what we'll do tomorrow. When we're talking about a 45, 45, this is the only isosceles right triangle that we have. Okay, got a text message. So here, the two legs are always going to be the exact same length. So it's n. Well, what's the hypotenuse in terms of a leg? It's n times what? Square root of 2. Yes. So really, we just kind of go through the same idea. That's what we're going to go ahead and take a look at tomorrow. Okay, good, good, good. Thank you so much. All right, let's get those calculators back up to the front, please.